My name is Chris Schmidt. I came here in 1978 from Albion College, where I taught for 2 years, and 4 years or 6 years at Knox College before that. But I came to teach, was hired to teach geophysics and structural geology, but I also taught physical geology, which we called 130, and I also taught oceanography. I started in Montana on my field work during my PhD, and I continue it to the present day, so that covers quite a few years. And I still do that. I still have a student, a graduate student this summer, working on geology in Montana. In the mountains, in the thrust belt and the Rocky Mountain foreland basement, the tectonics of that region. And so I guess I've been doing that for 40 plus years, 45 years now, really. And so that's my first love, and probably my last one in terms of geology. And so that my fieldwork and research are pretty much the same thing. And so I have written some papers, a lot of papers actually, with mostly with my graduate students on the geology of southwestern Montana. And in some respects, I'm the go-to guy on that region. But I've also worked in Argentina because it has a geology that's going on now, modern geology that's very similar to what Montana was back in 65 million years ago or so. So I've worked with a bunch of Argentine geologists in a region called the Sierras Pampeanas there, which is like the Rocky Mountains here, but the difference is that they're active. As well as the Precordillera, which is an exotic terrain that was actually, I helped to demonstrate that came from Laurentia, which is North America, during the Ordovician. So it's probably my biggest contribution to tectonics was helping to show that connection between that a good deal of Argentina and Chile are rafted in from what was then Laurentia, which is today North America, from the southern Appalachians. And I've worked more broadly in the Rocky Mountains. I have a couple of books that I edited, one with Ron Chase on the nature of the deformation in the Rocky Mountains, from New Mexico all the way to Montana.
I was a major player in the development of the hydrogeology program, but I worked closely with other members of the faculty, especially Lloyd Schmaltz and Nick Becero.
And we won the contract, which was $634,000. And the beauty of it was that it enabled us to hire about 30 graduate assistants to work on the project.
Yeah.
Now, what we had to do was to evaluate all of the geological materials available in the state and to somehow synthesize them for people who might want to decide on whether they would put in a deep disposal well or whether they would approve of a deep disposal well. We took it a step further, and I guess we turned out to be the envy of many other states, because what we did was we produced many maps, not only the ones that were available, like basic geology maps in the state, but we produced complementary maps of, let's say, groundwater contamination sites and that sort of thing. And we ended up with what was referred to as the Hydrogeologic Atlas of Michigan. And this was a very large publication, and it sold 100 copies. Because what it ended up being was not only resources to determine whether you could put in deep disposal wells. But it was a compilation of all of the geologic and hydrogeologic maps available in the state.
Now, a lot of this is what I did. I did the writing of the geology of the various formations, most of the writing of the geology. Part of the time I spent working for Big Oil, I was in Michigan working for what is now Exxon. And these units that are highlighted in here or discussed in here are the units that we were looking for oil in when I was working in Michigan. I worked in Michigan for 3 years and we lived in Grand Rapids, Michigan.
There was no requirement at the time that this atlas had to be part of our report to the Environmental Protection Agency. But the thought amongst the faculty at the time was that this was such a monumental effort and such a contribution to the state of Michigan, it would be, I think, inappropriate to see it housed in one small volume on an EPA shelf somewhere. So we undertook the publication of this, and we had to scrounge up expense money to produce that, and it was not cheap. But this was a major accomplishment, and soon after, I don't remember the exact timing, but the department also required a drill rig, which required additional funding because none was available within the university. So we scrounged up resources from wherever we could to buy a portable, self-propelled drill rig so that we could explore the glacial deposits in and around our campus and other places in the state of Michigan. So this is a major accomplishment I'm very proud of.
One of the advantages of having this grant, well, there were many advantages to having the grants, having that grant, because several students did master's theses on topics that came up as a result of our work. But just as important, maybe more important, it gave us the resources to get a drill rig of our own. This was a unique drill rig. Tom Straw and I went over to the Detroit area to talk to somebody who built these. This was a mobile drill rig, hollow stem auger drill rig, and with a trailer, and we ended up buying a pickup truck to haul it around with. And we were supported by a paper science department that was interested in the same sort of thing. Because what the hollow stem auger did was it allowed us to install our own monitoring wells. It's very difficult to do groundwater studies, particularly groundwater quality studies, unless you are able to put in monitoring wells. Well, this gave us the capability, at least down to depths of maybe 100 feet or so, of putting in monitoring wells for some of our own research projects, for just obtaining water quality, for offering services where this kind of drilling was necessary. We didn't compete with the drilling industry. This wasn't that kind of a rig. This was strictly a research rig. So we were often running with the capability of putting on our own monitoring wells. Now, at the same time this was happening, there was another national trend that was important. And that national trend culminated with CERCLA, the Superfund legislation. CERCLA provided a mechanism for funding groundwater and surface water contamination sites across the country. And they identified over 1,200 sites. Now, the importance of that number is that they also set up a fund. The petroleum industry and other industries had to put up so much money, which ended up being several $billions, to fund Superfund.
Yeah.
Well, that money was then available to engineering companies, groundwater research companies, people who could then look at everything from groundwater contamination associated with a gasoline station, with a landfill, with massive contamination sites at military bases. The main thing was that the money was then available, and where the money is, so goes the professional interest. Now, the importance of that to us was that most of this work was going to be done by engineering companies. Engineering companies hired engineers, and they didn't have a great deal of respect for geologists, quite frankly. But it wasn't very long before the engineers realized they couldn't handle these problems, not of their own. They could handle the cleanups and that sort of thing. But in terms of interpreting the contaminant movement underground, that was not within their capability. You needed hydrogeologists to do that. You needed somebody who understood the subsurface. So what developed at the time then was a whole host of short courses across the nation in everything from groundwater modeling to groundwater contamination to hazmat training. It was everywhere. And what it enabled staffs to do, people like myself, was to get up to speed in contaminant hydrology. For people who were interested, the training was available. Well, what that then enabled us to do was two things. It enabled us to develop a hydrogeologic program. But the interesting thing was that this was coming at a time, as I mentioned before, when hiring a petroleum geologist was not very dependable, up one year, down the next. This produced a program where our graduates were getting several job offers when they graduated in hydro, and not only getting job offers, but they were going out and starting their own companies, because there weren't that many companies around to handle all of these contaminant sites. So some of our graduates just simply started by developing their own companies. The federal legislation, and which were translated then into the state efforts, because the states were picking this up, the groundwater contamination. We consulted on, for example, the KO landfill, and did the basic work on the KO landfill. Tom and I both were expert witnesses in cases. There were geologists were serving as expert witnesses in many of these cases. One of the first ones, which I forgot to mention, was the Love Canal project. Mike Stoleen from the math department, who was a statistician, was a consultant on the Love Canal. So he actually started into this business almost at the same time we did. The beauty of that was we had a nice relationship because Mike provided the statistical basis for a lot of the research that we were doing, a lot of the work the students were doing, particularly things like regression analysis. So it became almost an interdisciplinary type of environmental or hydro effort. Developing the program was sort of interesting because what we did was to develop an applied hydro program. Ours was not a theoretical program, it was an applied hydro program where we trained students to actually go to work. When they graduated from Western, they would go to work. For example, we developed the field course in hydrogeology where we used our drill rig, we took students into the field, we had them put in monitoring wells, we taught them what a split spoon sample was, how to collect samples, how to analyze them, how to log these wells. And we were fortunate enough to have a number of professionals come in and supplement our staff that way, help out with that field course. The field course fairly rapidly developed a national reputation, and I think even to this day it's well known, even in parts of the world, not only in the United States.
When we started building the program, we found that we really didn't have a good way to teach people how to be a practicing hydrogeologist. There was an engineering firm in just east of East Lansing, and they agreed to help us set up a hydrogeology field course. And they let one of their employees, Mark Zalewski, come and direct our field course for us, and we worked with him then to develop it. And then we developed that, and it went very well. It was very well received, and our students certainly gained an awful lot by it. And then we did it a number of times, and it seems it's still going on.
I think a lot of what has happened in more recent years is a result of the work that has been done by the advisory council in the department. And this was an endeavor that I and the faculty undertook because we saw a lot of merit in its potential. Only one other department on campus had an advisory council, and that was kind of a separate entity in the Department of Paper Technology. They had an advisory council. Distinguished workers in their industry and distinguished alumni and so forth came back and served the Department of Paper Technology. Well, all of those concepts would be valid for the Department of Geology. And so, lo and behold, we were able to get the state geologist on board the council. We were able to get alumni from our department and some local business leaders in the community and other representatives in the mining and in the petroleum and refining industries, so that these were essential members that contribute in the advisory capacity, helping the department resolve issues, making contacts in industry and business for student applications, and also to make contacts for them to come and recruit in our student area.
The advisory council was the brainstorm of Dr. Schmaltz. He called me in 1982 and he asked me if I'd be interested in coming back to help with the department and the university. I asked him what was this about, and he just kind of gave me a quick overview. I said yes, I would. And so in '82, the first advisory council was set up, and it was made up of some of the key business leaders in Southwest Michigan. And Jim Duncan was one of those people, and there were other people from around the city, the state, as well as from the oil industry and other things. But I served on the council for 33 years. I was chair or co-chair for that period of time, and it was another thing that really helped bind me to this university, is that so much was given to me and I wanted to give back. And so when one volunteers, that's what you give back.
A little over 30 years ago, when I was still a young faculty member, I had an opportunity to take what they call a professional leave or a sabbatical. Once every 7 years, faculty members are entitled to write a research proposal, and if it's accepted by the university, they'll give you that year off to do research, and you can choose the subject matter that you want to do. And I decided that as we were evolving with some of my students, looking more about Michigan geology and realizing that there were lots of Michigan problems that had not been really identified, and that we needed to have much more additional knowledge about the underground environment in Michigan, I started contacting some of the oil and gas companies that were around the state that had been drilling these wells, and they were more than happy to give us any kind of help and information, and we developed many partnerships and lots of relationships between the private industry sector and our academic world. And these companies had warehouses full of samples from wells that they drilled, core samples. They're called the long cylindrical pieces of rock that they get when they drill a well, or other pieces of information, electrical logs, which are remote sensing measurements of those different kinds of environments in the underground setting. and information about how the well produced, whether it was a good producing well or not so good, all kinds of analytical testing and things. And the more people that we talked to, the more we found out that there were just archives of this stuff all over the place. And it soon became obvious that there was a need to have a sort of statewide facility where this material could be collected and housed, kind of a library of the geology of Michigan. And so when we first started, I just had a few things, and our departmental chairman, Dr. Lloyd Schmaltz, found a small room, a laboratory in the geology building in Rood Hall. And I soon was able to fill that up, and he found another space. We moved all that collection over into the basement of the second oldest building on campus. It was on the old East Campus at the time, and that building's no longer there anymore, but it was a building called West Hall. And we've at first just had one room in the basement of that building, and then we just kept getting more collections and expanded into the next room, and finally we occupied the whole basement level. And then we started asking for more space and got rooms on the first and second floor as well. So this collection just kept growing, and it was almost this sort of field of dreams process where if you build it or if you make it available, more people want to come and give you stuff and study what you're doing. So it just evolved over time.
In terms of the research activities, I brought with me from my previous institution, the Colorado State University at Pueblo, a NSF grant, and then proceeded to get 4 more NSF grants, co-authored by other people, of course. And these dealt with Rocky Mountain tectonics in some way, shape, or form. The earlier grants dealt with the Idaho batholith and its role in the development of the plate tectonic patterns of western Montana. The later grants dealt with the development of Rocky Mountain foreland folds and the role of the basement fabrics and compositions in controlling those folds and faults. That was done with Chris Schmidt.
There's 4 people that I feel that had a lot to do with my success at the university, and that was Tom Kamen, Jerry Aiken, Paul Daniels. And it was probably about 10, 12 years ago that we named ourselves the Core of 4 because we have had a personal, professional relationship with each other for almost the entire 50 years, except for possibly about 10, 15 years when we first got out of school. We were all focused on our jobs. Subsequent to that, it's been great.
Then, because of this national trend and the awareness of the need for groundwater protection, Michigan State was able to get their funding from Kellogg. I doubt that Kellogg would have been that concerned if this hadn't become such a national issue. Because prior to this, people weren't really that concerned about groundwater and groundwater contamination. But when it was exposed, it exploded. When Michigan State University submitted a proposal to the W.K. Kellogg Foundation to educate the public in groundwater and groundwater problems, which was to be called the Groundwater Education Project, GEM. They received a grant for, it was I think over $500,000. And part of that grant was to have designate universities as consortium schools. These universities, as part of the GEM program, each had different responsibilities, but they certainly had the responsibility of developing materials locally to educate the public in groundwater. We were fortunate enough to become one of the consortium schools or centers, and so we became a GEM regional center. Now, our primary responsibility at the time was the groundwater component. We were the only school that in the consortium that had the expertise to teach the technical aspects of groundwater. At Western, we also developed what was called AquaPro. AquaPro stood for Aquifer Protection, and it was simply an algorithm which allowed us to use the well records and certain criteria from the well records to give an estimate of how protected the aquifer was in that area. And it was it received widespread attention because nationally they were also working on other algorithms for groundwater protection. It was, you know, things were happening fast and furious in the country. But this algorithm fit into the GEM program very well, and it pretty well shows the kind of involvement that Western had and how we used our technical expertise for the GEM project. At the time, we wanted to take it a step further, and so we thought we should have an Institute for Water Sciences at Western. There was no holding us back at that time. So the Vice President for Research, who was very nice and a very good friend of ours, gave us a grant to start the Institute for Water Sciences. And as a result of that, we hired a nationally known, actually internationally known hydrochemist. This is one of the newsletters that they put out. And this is Mike Barcelona. Mike was an extremely interesting person. He's a hockey player, which gives you some idea of what his personality was like. He didn't quit on anything. But he came to Western from the Illinois Water Resources Survey, and was in charge of 20-some scientists working on that. And he had multi-million-dollar grants and was an expert in groundwater chemistry. So he was a real feather in our cap. But Mike came with the idea of big universities and big grants. And he fully expected, as did the administration, for the Institute for Water Sciences to become self-sufficient after that first grant. And we were doing pretty well. We had a few $1 million there for a while. Mike was educated in Puerto Rico, as I remember, and he really was an oceanographer, but he also had a position in the chemistry department at Western, and we hired a lab analyst and built a groundwater or a water chemistry department. And the beauty of this, it was in-house. Then as students did research on groundwater, they could get their samples analyzed in our own lab. And first of all, they didn't have to do it themselves, which would usually be beyond their capability, especially with organic chemicals. And you didn't have to have a grant to pay for labs outside the university to do it. So it was working very, very well.
My name is Al Kehue, and I came to the department in 1986. I was previously at the University of North Dakota and the North Dakota Geological Survey for 9 years before coming here. I came because the department was developing a strong reputation in water-related research, and they had received a grant from the Department of Commerce called the Research Excellence Grant, and Dwayne Hampton and I came initially to work on that grant.
I'm Dwayne Hampton. I got my bachelor's in geology at Michigan State University, where I learned one or two lessons that I remember. Most of them are gone. I got my master's in civil engineering at Auburn University in Alabama. I got my PhD in civil engineering at Colorado State. And my interest in switching from geology to civil engineering was the confluence of energy storage and water. I thought that there was linkage between being able to use energy more efficiently and using water. So I studied that at both schools. I worked briefly as an environmental consultant at Environmental Research and Technology, or ERT, in Fort Collins, Colorado. And I came here. I saw an ad for a research position under the REF funding scholarship. The state of Michigan's legislature gave Western Michigan University a couple $100,000 a year for 5 years to do groundwater related research that would hopefully enhance the economic productivity of Michigan. And Dr. Kehoe and I both came here under that funding in more or less strictly research positions, although we were allowed to teach a course a semester. But I think the folks who brought us here, Dr. Richard Pissarro and Dr. Tom Straw, had sort of a bigger vision in mind. When I came here in December '86, I came to teach in my spare time and do research full-time doing groundwater modeling. I didn't have a computer. There was one computer that was in 1142 Rood Hall. It was a compact with an orange screen. It had 5 meg of storage, not of RAM, of storage. And that was the computer that we used for teaching and doing research on groundwater modeling. It was far less capable than your standard flip phone, old-fashioned, not even smartphone. That's what we had. So things have progressed quite a bit since then. The very first summer we were both here, Dr. Kehoe and I, was the first summer of the hydrogeology summer field course. The first year it was offered by Western Michigan University, but led by Dr. Marek Zalewski, who was hired by Keck Consulting in Lansing. They had an office in Kalamazoo. And basically Marek, who had led the field course at Montana Tech, showed us the ropes. He introduced sort of 3 weeks of the field course curriculum that we still have. A week of drilling, a week of sampling, and a week of geophysics. Or actually, no, pump tests. I think geophysics came later. And he directed the field course the first 2 years, summer of 1987 and 88. And then in '89, Keck sort of pulled back and we took over and have basically doubled the duration of the field course and have offered it, I think, every summer but one since the inception in 1987. Some years we even taught it twice.
My name is William Sauk, commonly known as Bill, and I first came here in the fall of 1979 and spent 4.5 years at Western at that time. And then I had to go back to Brazil because My wife at the time was a Brazilian citizen who had come here also to get a PhD at the University of Michigan during those 4.5 years. And as a obligation of her fellowship from the Brazilian government, she had to go back and work in the Brazilian federal university system for 3 years to pay it back. So rather than split up, I went back with her. I asked for a 3-year leave of absence, but the dean at the time refused, so I resigned. I was forced to resign, basically. So then I was gone for those three and a half years back in Brazil, and we were able to get fellowships at the University of Wisconsin-Madison from the Brazilian government to do postdocs, basically, and so I spent 2.5 to 3 years there, and then we got a call from somebody here at the Institute for Water Sciences and offered me a position at that, which was not really part of the geoscience or geology department at the time, but very close, and we were housed in Rood Hall. So I had a number of years there until that was closed, and then I was nicely folded into the geology department again. All this started in 1990 when I came back to Western for the second time, and been here continuously since then.
So, when Al Kehoe and Dwayne Hampton came, we were able to expand the program because Dwayne was able to teach courses in modeling, and Al Kehoe was able to teach things like engineering, geology, and geochemistry. And we also had the advantage of having Bill Salk come back to the department. Bill Salk is, the kids used to call him the wizard. He taught applied geophysics. And why was that important? Because things like ground penetrating radar were used to find underground tanks and that sort of thing. So we had the geophysics component of the department. So we had the hydro component with Al Kehoe and Dwayne Hampton. We had the geophysics component with Bill Salk. And the program with the field course was then off and running.
Hi, my name is Dave Barnes, and I'm a professor here at Geosciences Department at Western Michigan University, and it's a real pleasure to be involved in the 50th anniversary celebration that's going on. And I haven't been here for 50 years, but I've been here a pretty long time, 30 years I think, coming this August, and came to Kalamazoo from Dallas, Texas, as a detour from San Francisco, where I work in the energy industry, and that was in 1986. It was one of the many bust times in the oil and gas industry, and I was fortunate enough to have some expertise that was of interest here at Western. So in 1986 I came to Western and was really attracted to the potential of working in a major sedimentary basin, the Michigan Basin, and the core repository facility, which was in its very beginnings, was also a very appealing opportunity. Also, coincidentally, despite the fact there was a bit of a downturn in industry, there was quite a little mini boomlet in terms of exploration in a sandstone unit here in Michigan. So I got involved in that in the middle 80s, and that was sort of the wave that I rode initially here as a research-hungry young faculty.
One of the programs that I thought helped us and the people who took it very much was whenever we found a provision in the graduate catalog that people who had a master's degree in which they had completed a thesis could get a second master's degree in a related field by taking 20 hours of coursework and no thesis. 20 hours of coursework, and as I recall, we gave them an examination. But at that time, it was one of those periods when the oil companies had let quite a few G&G, geology and geophysics people go, and they were looking for a way to find themselves in another job, and they needed some bridging education. That um, was quite a problem for the people coming out of the oil and gas industry. And the federal government responded to that by funding their education. And our secretarial staff became very good at facilitating getting the money for them to take that program. And so we had quite a few people who actually got a second master's and went back to work. Almost all of them went into the environmental thing, others didn't. When I became chair, at the very first faculty meeting, just like I say there, I said something to the department faculty about naming it after Lloyd. And they all looked at each other and said, I didn't know he'd like that named after him. And I'd found that out. He and I were talking one time, way back, after we moved in, it was probably, sometime in the early 80s. And I said, when you guys were planning the building, I sort of gathered that Dave Kinsey did most of that museum work. Oh, no, he said, I did that. And I didn't know that. And I was moved to believe that because whenever I talked with Chuck Harrington, who was one of our graduates and my study partner in the PhD program, we studied a lot together, and he's one of our graduates at Western, one of our honored annual people, and he talked about how much Dave Kinsey worked in the museum. Well, the museum that Dave Kinsey worked in was the teaching museum. He was working to get the collection so he could teach paleontology and earth history and things out of it. And I knew that Lloyd had actually gone to Europe and brought back the plesiosaur and the big coelacanth and all of that. And so he'd done so much, it just seemed to me, and he'd been so important to the department, it seemed to me that it would be really the thing to do to name it after him. And so as soon as I brought it up and explained my thinking about it, they were all, they thought that too. They just did not realize that he'd done all of that work on it because after all of them but Dick Passero came after I did.
Field trips have always been part, whether they were the first field trip I took to the Upper Peninsula or whether they were the summer field trip that we offered, not only in fundamental geology up there, but now we also offer a field activity in groundwater. So the focus has been on field trips to the Ozarks, to central Wisconsin, to the Appalachians. No matter what, field trips were part of what we wanted to do in the department. In 1973, I started a field trip to the Grand Canyon after having participated in the National Science Foundation trip down the Colorado River through the Grand Canyon. The trip was a student-oriented trip. Students took classwork here before we left. And then we spent approximately 2 weeks on the road visiting the Rocky Mountains, the Colorado Plateau, looking at the complex geologic structures that they have in the West that we don't have here in the Midwest. And the last 3.5 days were spent on the Colorado River, traversing 90 miles through Marble Canyon and so forth. And then the dreaded hike out, a 9-mile hike, climbing to the top of the rim with our backpacks and so forth. Looking at the formations along the way. We got a complete experience with the section in the Grand Canyon. And so that trip was continued for a number of years. Cost kind of caused it to change a little bit because the lengthy trip and the high cost of transportation and the high increasing costs of the raft trip portion of the trip. So the trip was reoriented to one working with the foundation, Western's foundation, and we recruited members in the community, alumni who could afford the trip. We were flying directly out to Las Vegas, and then we would rendezvous at the drop-off point and take not a 90-mile trip, but closer to a 200-mile trip down the Colorado River. And these trips, I think, went on for a number of years. My recollection is I think I did a total of 18, and many of the people still report to me about that was the one experience in their lifetime they'll never forget. And so I'm proud of that. I think many of them have been supporters of the department by way of the foundation, and this is, I think, one of the crowning achievements.
A program was developed to digitize all the well records in the state, water well records in the state. And as a GEM regional center, we had to hire a director. Dave Dickerson and I interviewed people, and we chose Lauren Hughes, which is probably the wisest thing we ever did. Lauren was so good in almost all respects in terms of leadership that she was able to oversee the GEM program. Everything from not only the digitizing, use of digitized well records, but also some of the other work that was done, like the publications. In fact, what happened was GEM was able to hire Sid Delaney. Sid Delaney developed a good bit of the software. And with that software and using the digitized well records, we could produce maps from those well records of everything from depth of water table, thickness of clay layers, depth of bedrock if it existed, just about everything you needed to map. And we produced publications such as these. And these were used by townships or counties, and they contained an overview of the hydrogeology of that particular geographic unit.
As we began to delve more into Michigan geology and these students began to be more interested, I started developing relationships with some of the independent oil and gas companies that operated here in Michigan. And a number of our students had gotten jobs with those companies over the years, and so they were more than happy to give us information that we could use in our teaching part of the program to help train the students. And they would also give us samples. We got core samples from the wells that were drilled. We got drilling samples. We got all kinds of data from the individual companies. And we started building a collection here of Michigan geology data. And one of the things that we were learning was that even though Michigan, the geology of the Michigan region is written up in textbooks a lot and is thought to be a classic historic kind of geologic setting, there was an awful lot that we didn't know about it. So it actually worked out quite well that we were able to do these kinds of research projects.
I decided upon coming here that I would focus on an issue I ran across as a consultant, which is oil, gasoline, and solvent spills into groundwater. Even though my background at the master's and PhD level was in groundwater modeling, and I was planning on teaching that and using that, I decided the real need in our profession was to have better tools and better understanding of how to deal with spilled fuels and lubricants and solvents. So I took my $1,000 startup money and bought a plexiglass box that was 4 feet tall, 4 feet wide, a foot thick. It was made by a local plastics manufacturer. And we installed some well screens that had been cut in half lengthwise on the side of this plexiglass box. Of course, plexiglass is a plastic you can see through. And then we filled it with sand, very finely packed so that it was as uniform as possible. We put water in there, and then we put kerosene dyed blue in there, which we could distinguish from the water, and we're interested then to see how that would show up in the different wells. We had wells of different diameters. Later we had wells of different gravel packs. We also tried wells made of different materials. We tried gravel packs made of different materials, including some that were made with hydrophobic materials, meaning water repellent materials, such as granulated Teflon or sand which had been sprayed with a camp dry, a water repellent chemical. And in a nutshell, what we found is that we could recover more or pump more fuel out of the ground if we used water repellent gravel packs around well screens that had the maximum open area possible, and the size of the gravel pack needed to be different than the traditional gravel pack grain size distribution for water wells. So that was what I felt was a worthwhile contribution to our industry. And people are still contacting me about how do you get this water repellent gravel pack, which turns out not easy to do. We had mainframe computer actually up on the 3rd floor of Rood Hall. That was the computer center at the time. And some of the work that I did with grad students was on that mainframe because, again, the little compact didn't have any guts. Obviously, things have changed since then. We've got a computer lab in 1136 Rood, which has been renovated several times. That I was a contributor to making those things happen. And then we have a computer lab over in the basement of Wood Hall, which we use not only for our intro classes like 1000 and 1300, but we also use for the hydrofield course in the summer.
Projects I started here was a study to look at the Schoolcraft aquifer with Tom Straw, and we put in quite a few monitoring wells there. There were several thesis and dissertation projects, and we also then sometime after that started a project in Cass County looking at the effects of non-point source contamination, like runoff from fertilized fields and so forth, and particularly how that contamination moves into groundwater and might have affected a large recreational lake down there, which was called Donnell Lake. So that also took us a few years and ended up being a very interesting project. I've always had an interest in glacial geology, and one of the things I've studied over time has been how the giant lakes that formed as the ice was melting, how those drained and discharged, creating some of the major valleys. In fact, most of the major valleys in the mid-continent of North America were formed by glacial drainage. So I spent some time in Canada and throughout the Midwest of the U.S. Studying those valleys and the landforms and the deposits from those outburst events. We had an institute here called the Institute for Water Sciences, and one of the projects we got, and this was primarily Mike Barcelona's project, was to look at potential lead in drinking water in Grand Rapids. And Grand Rapids receives its water supply from Lake Michigan. It's very soft water, so the source of the lead, which was the focus of this project, was actually from being leached out of pipes in households. So the water came in, and because it was soft, it leached lead and other metals into the drinking water, particularly in older houses.
With the Institute for Water Sciences, we were fortunate to get one major piece of capital equipment, which was the ground penetrating radar, which was fairly new at that time. In fact, this was the first digital GPR system out there, and we got that, I think, about 1992. And I've had that and kept it running ever since, in fact, with several upgrades. But our first big project, or series of projects, dealt with mapping the sand thickness offshore Lake Michigan, near shore, in the near shore portion. The U.S. Geological Survey had been mapping the sand budget further offshore with their larger vessels using seismic means and things like that. But they would have to turn around when they came within a half mile or mile of shore, not wanting to run aground with these bigger ships. So they had this key zone where most of the sand really is, and all the moving sand is between the shoreline and about 25 feet of depth. So we were contracted to somehow determine the sand thickness, the modern sand thickness, the movable sand thickness to put into their sand budget for that. So it was an interesting project, but kind of scary sometimes because we didn't have the benefit of weather radar and even radio on the boat, and we were off. Most of our profiles were 10 to 20, 30 kilometers away from a port. Ports are few and far between. On this near shore Lake Michigan, there's no shelter anywhere in between. So a motor failure or sudden storm coming up, and you have to be careful. But we tested a couple methods, but decided on the ground penetrating radar, and we innovated in that we put the antennas on a weighted sled and dragged them along the bottom, and that hadn't been done before. Previous attempts in lakes in the northeast of the country, where the water is very low conductivity, very soft water, use floating antennas, and they could get some penetration in the bottom. We tried that, but Lake Michigan water is a little bit more conductive and attenuates the radar signal, and by the time you're out in 10 feet of water, it's pretty much gone. So I had to put the antenna on the bottom. So that means weighting some kind of a sled and keeping it down there and keeping it dry. So there are a lot of challenges with that. But it worked very nicely to get about 20, 25 feet of penetration into the bottom, uniformly from the shoreline out to as far as our cable would let us go. And we did transects, shore perpendicular transects from Erie, Indiana, all the way up to past Muskegon and all up to almost up to Manistee. In fact, we did more work around Manistee with Dave Barnes. But in all, I think we covered at least 25 kilometers of transect of underwater radar, and saw some very interesting things. And the second and third years were financed by the U.S. Army Corps of Engineers, and I had done some more lines for them and repeated some lines. They were interested in the changes from year to year.